Hi, my name is Jeff with Doodle Labs. I'd like to thank you for taking the time to watch our video on Smart Radio Link Diagnostics, how to measure maximum link capacity and real-time data traffic over a smart radio network. So first we'll go over how to measure maximum link throughput. The utility we'll use to do that is iPerf3. It's basically built on a client-server model. It allows you to measure your maximum UDP, TCP, or SCTP throughput between client and server stations. The website shown here is where you can go to download, get access to more information on it, additional commands you can run, and then actually a copy of it should you need to load it on your host system. In most cases, and in the case of Windows 10, it's already preloaded utility. The same with our smart radio. Each of the smart radios has the utility iPerf built into it, and we'll be showing examples of both through the course of the video. In the instance of the embedded iPerf on the radio, one radio will act as server, one will act as client. It doesn't matter what role is assigned to either, but you need to keep in mind when running the radio's iPerf internal utility, due to the CPU overhead to generate the traffic and measure it, you're only able to generate and measure approximately 50 to 66% of the link's maximum throughput. So keep that in mind. And if you have the ability to plug into one end of the link on either end, you can run iPerf from your PC, and at that point generate the traffic from it, and you'll get the true 100% reading of the link in terms of maximum throughput. The utility does use application port 5201. So you'll need to establish a firewall rule on the server radio which allow access to port 5201 for the client traffic connected to the server. So opening up that port on the server radio will be key to making that connection through. We'll show you how to do that next. The setup's going to look like the following. On my bench, I've got an external smart radio that'll act as the iPerf server with this default IP address here. We'll have a wearable smart radio acting as a client with this default IP address. Then we'll use Ethernet over USB cable to connect my host PC to the network through the client device, smart radio. We'll need to establish or set up on the NIC a static address in the same subnet range as the client server radios, and that will be in the 10.223/16 subnet. So now we'll have to open up the port in the firewall and through the GUI actually, and we'll do that on the server radio. So we'll log into the server radio and go to Network Configuration and Firewall. We'll click on Traffic Rules at the top of the page and then scroll down, and we'll go to Open Ports on Router section at the bottom of the page. And the first thing we'll do is enter the name that we want to assign to this rule. In this case, I called it allow iPerf3. Take your pick what you want to call it. It really doesn't matter. It's just a mnemonic there. The protocol, however, can be either TCP or TCP and UDP. I chose TCP here because that's the test we'll be running, but should you want to use different extensions in iPerf, you can run UDP tests as well, so you can do TCP and UDP here in terms of protocol. And as far as the external port, we'll label that port as 5201 on the firewall, and we'll hit Add, click on Add, and then Save and Apply, and we'll have this rule established. Now keep in mind, however, the firewall setting you do does not survive a reboot, so it's good while the course of your testing, but if you have to reboot the radio at some point, you'll have to go back in and reset this firewall switch. So let's go ahead and log in and do just that, and we'll set up this particular rule on our smart radio server radio. Okay, so in this case our server radio is 10.223.82.60, so I'll go ahead and log into that and go ahead and find our appropriate settings. So as we said, we go to Network Configuration. Once logged in, Firewall, and we'll go to Traffic Rules. And we'll scroll down to Open Ports on Router and input new rule, in this case allow iPerf3. and we'll go ahead and protocol TCP. Like I said, it can be TCP and UDP, so we can do that. That's fine. The port we're going to connect is 5201. Add. And then we'll go down and we'll hit save and apply. All right. So the rule's been applied. If you scroll down, you'll see it. There's a very last rule here. And it's TCP UDP, allow iPerf3 any host, and accept input and check. So the rule has been taken. Let's go ahead and continue and show you how to actually set up iPerf session through the CLI. So as I mentioned, it's a CLI command that we can utilize internal to the radios to generate the traffic. And what we'll do is we'll have to log in through CLI, which we'll do. To do that, we'll get into the SSH shell, and we'll do that by logging into the following command: SSH space root at, and then the IP address of the radio in question. In this case, we'll go into set up the server first. However, when you log in, if you get this error message saying your host key has failed, your verification has failed, you'll see this typically if you just upgraded firmware and you just have a fresh version of firmware on the radio. You'll get this error message when you first try to log in through the CLI. So to get past that, you'll run the following command at the command prompt: SSH-keygen space dash capital R, and then the IP address of the radio, in this case the server radio. It'll let you in. So let's go ahead and once you get in, you go ahead and log into the server, and we'll enter the following command, and it'll be iPerf3 space dash S, and you'll see the following setup and output: server listening on port 5201. So let's go ahead and log in and work our way through that. So we'll open up a command prompt on our radio. On the PC, actually getting to the radio, we'll go ahead and try and SSH in. Oops. Okay, and wouldn't you know, I've got the block, the error message that the key has failed, or I don't have the right fingerprint. So to do that, again, to get past this, we'll go ahead and reset the key by entering the command SSH-keygen space dash R, and the IP address of the radio. Okay, now we'll go ahead and proceed to log in. And do I want to continue connecting? Yes, I do. And now we're in the SSH shell on the server radio. So let's go ahead and establish it as the server. And we're good. We're listening on port 5201, so that's one half of the equation. So now let's go and do the client side. The exact same sequence: string commands SSH root at the client radio side, in this case the wearable. And once we're in there, we'll enter the following command: iPerf space C, iPerf3 space dash C, space the iPerf address of the server. So remember, we're going to be sending the data from the client to the server. So we want the client radio that we are logged into, pointed to the server, and then the string we'll add at the end here is dash T, lowercase t10, which tells it the rate that we're going to run basically 10 consecutive tests sequences, and the space between the tests will be 1 second. So 10 consecutive tests at a spacing interval of 1 second per test. You can do any number of tests, it's up to you, but each one of those tests will take a second in time with this extension. If you want to reverse the traffic and have the traffic sent from server to client, you can do that. enter the same command, but at the end of it, command string ash, you'll add a dash space dash capital R to the command. That'll take the traffic from the server back to the client. So let's go ahead and log into our client radio and run a test. Okay. Command prompt. So now we'll log into the client side. Okay, and we'll go ahead and set up the stream. Back to the server. So again, as we mentioned, we can run one more time. As we mentioned here, basically you're running it on the internal CPU, which can't generate as much traffic and measure simultaneously. So the numbers here are going to be a bit less than we would see when we run it connected directly from our laptop. But let's go ahead and we can also run it now in the reverse direction. Space dash R at the end, same command. Run in the reverse direction, and get a little bit higher numbers going from the outdoor unit. So again, this is all going to be derated because of the CPU overhead. So now what we can do is let's open up a third window and go ahead and we can see these numbers, and we'll go ahead and run it from our laptop, as I am directly connected to the wearable. So I just run straight iPerf. And see what we get for results. So the other results were 10 or 17 megabits respectively. Let's see what we have here. So these numbers are 27 megabits, so almost double. So about 50. We got about between 50 and 60%, depending on which direction we ran, of the actual throughput. So that being said, if you have access, you can run it off your laptop, or if you don't, on links that are a hop away from you or more, then you can run it with the embedded utility. So you have two options there on how to do that. Okay, now we're going to go ahead and go to a utility we have built in that allows us to measure the real-time data traffic coming over a designated interface. We get to designate the interface, and it'll give a real-time measurement of the actual traffic that's being transmitted over that particular interface. So what I want to look at in this instance is our interface for the mesh radio, which is WLAN 0. So what we'll do is we'll SSH back into one of the radios, and we'll see what the traffic looks like coming over in both directions, coming over that interface, in this case WLAN 0. So the following will SSH in, and the following command will be run bmon space dash b space dash p space WLAN 0. We can pick different interfaces, but in this case I want to see what's coming over the mesh radio, and we'll go ahead and enter that command in through the command line. So we already have an SSH session into the radio. In this case, this is what is our client radio, the wearable. I'll go ahead and run this command. Oh, it's been reset. So we'll go ahead and reestablish the command here. And now we'll run our traffic measurement tool. So this will give us a real-time data. This is telling us what's coming over. Not a whole lot right now. It's in kilobits. There's no traffic being sent other than pings. I mean, other than the measurement overhead data. So what we can do is we can kind of increase this quite a bit. So we'll keep this running. And a good exercise will be we can run iPerf at the same time. So let's go ahead and log in. Let's see if our server's still running, which it is. Server's still listening. We'll go ahead and go in through command line, again into the client side, and run iPerf, and we'll watch the measurement when we're running a test. So let's set up our session. We'll go T20, we'll do a few more runs here. And let's see what we got. It'd be nice if we got the command right, iPerf 3. All right. So you see our numbers bounce up a little bit. So transmit, this is the transmit port. So we're still, the receive side is not getting much coming back from the server, but going to the server, the transmit side, we're seeing real-time measurement of what the actual data is being sent via iPerf. Now, what we can do is we can reverse this, and we'll see it reverse direction. So reverse direction, we'll start seeing it here on the receive side. And our transmit numbers will be reduced dramatically, which they are. So again, this tool is a good tool to utilize when you want to see what traffic's going to be running video or other applications, and you want to know what's coming over the interface. This is a way to passively monitor that and give you a good idea of the traffic flow coming over real time. I want to thank you for taking the time to watch our video on measuring throughput and traffic over Doodle Lab Smart Radio Network.